this video is being made for our presentation for NCTM 100 on coding math at a distance. And I'm going to start by just jumping in and walking you through how to set up the basic simulation model. So we're always going to start in the events menu. We're going to pull out the screen flag. I'm going to blow this up a little bit for you. And if you look at it the way we had set it up, we were trying to model first we were trying to model just a number cube. So in thinking about that, what we want to do is we want to make it so we can store the outcome in a variable. Let's go ahead and make a variable. Some people are really specific about the way they like to do this. I'm just going to make it outcome with a capital O. Some people like to never use capitals at the beginning. But then we are going to say, okay, let's pull out this set my variable, and we're going to set it actually the outcome to a random number. So if you're thinking about that, in the operators, you have this pick random 1 through 10. So the number cube has the options of 1 through 6. And if I actually just take this out and click it, you'd notice that it's going to generate random numbers, right? Pseudo-random numbers, I guess. And we want to set that outcome to a specific value. Now, let's say we wanted to do 10 rolls. The way we're going to do that is just loop this 10 different times. And I will go into the control menu and just put a basic repeat on there. And now again, if I link this in and click the green flag, it is going to do this 10. It does it so fast you can't even see the value here change. So we're actually just going to store it in a list. And you can call the list anything you want. It's in the same place we made the variables in the variable menu. Down at the bottom it says make a list. And we're going to say trial results. We got in the habit after teaching some computer science classes to use underscores. I always try to make things just a single word. It's also good to model for kids. But all right, so we have our results, and we want to add every time we roll. We want to add this outcome to this list called trial results. And so we have stored in this block. Right now, for example, the last outcome was 6. So if I click this, notice how 6 is stored in that variable at the moment. And so I'm going to add that outcome to the list. Now, when I run this and click it, notice that those 10 values populate. I can resize this if I want to, and so I can see all the results. But notice now if I click the flag again, it's just going to keep adding 10 more and 10 more and 10 more. And that's okay if that's what you want, but usually we want to initiate all the resetting and clearing of things. So there's this option to delete all of the trial results, or you can change that to any list. And now if I run this, I can either run it by clicking the flag here or clicking this top bar. Notice that the length here is 10. It's resetting the list every time. So that's a good point to get started at. I'm going to pause and let you get caught up if you're behind. Okay, so you can see now that I added in here just a basic concept kids should first understand about probability is that it's the number of favorable outcomes or successes over the total possible outcomes. And that's really a strong starting point for them to grasp. So that's what we're going to introduce. We're going to create 2 variables. The first we're going to just call successes. And that would allow it so that if we changed what a success was, instead of like a 6 or whatever, if I called that number of 6s, now it can become multiple things. I'm going to create a second variable called probability. And those 2 show up here. I'm going to leave them show up. Now, if you want the things to hide up there, notice if you uncheck these boxes, they go away or reappear. So it depends on what you want to be seen over here in your actual stage, I guess it's called. All right, so for this particular one, let's say we want a 6 to be a success. Well, in our tutorials, we talked about how that would require some type of if-then conditional. So I have this if-then conditional, and we want a Boolean expression that will test and see if it's true or false. So I would say, is the outcome. Now, you can always go back and drag the blocks out from here. One thing a lot of beginners don't know is that you can actually, if you want to, you could right-click on a block out here and duplicate that block. So I'm just going to showcase that. If the outcome was equal to 6, we're going to drag and drop this in here. If this condition is met, then execute the code inside of this block. And so to do that, we'd want to do what's called incrementing. Now, Scratch actually has a change block. Not all languages have this, but you could always just also manually reset outcome to outcome plus 1. Or I'm sorry, successes to successes plus 1. So I would say increment this number of successes by 1, and I'm going to do that. It really doesn't matter here. It has to be after the roll. So this, remember, simulates our roll. So yeah, I guess I'm going to put this one above it. You can always restructure your blocks, but I'm going to add it to here, and then I'm going to check it. And if it is right, if it is a 6, I'm going to increment this number of successes up by 1. All right, and then for the probability, then I just want the number of successes divided by the total possible. Now, it's nice with this program, and with other languages, there's usually something that determines the length of the list you've made. So notice if I scroll down on my list blocks, there's this one that says length of trial results, and if I click this, there's a 10 stored in there. So it knows the length. I don't have to create a new variable, although I could create a counter that counts up each time a number is added to it, but this is an easier way to do that division. So then I'm going to quickly pull in a set. I'm going to do this down below. So set probability, and I want a simple just division like the definition would say, the formula. I would want the number of successes. So I'll go to my variables and pull out number of successes divided by total possible, which is stored in this length. So this should set the probability to whatever is there. And then you could always have your character. Let's say I wanted my cat to display that. I could go to looks and I could just pull out a say block. You can do it for a certain period of time. You notice how he says hello. I'm going to pull it down a little bit because it looks like he talks above. So see how he says hello there. I'm going to just do it for, let's say, 4 seconds. You could change how long it is, but I'm going to say what the probability is for 4 seconds. So there's the code structure. You could pause or rewind or whatever you needed to do, but I'm going to execute this. Should repopulate. I've got 1 6 in this list, the 6th trial or the 6th outcome. And this time, wow, I got 6. That kind of is an outlier there. So I got 6 successes at 0.1. And again, what we can do is very quickly now, since we're resetting it every time, we can change the number of trials to, let's say, number of rolls to 100. And it could just as quickly populate 100. So 16 of these 100 are 6. So I'm going to pause there again and let you get caught up and do a couple things just to finalize. Okay, so to end with, what I thought we could add is some people probably had questions just about, like, I showed some of the data science pieces, but wondering how in the world is that, like, let's say, averaging algorithm happening. When you start to get an account set up, and you should create an account, there will be this folder that shows up, and I wanted to show you that you could sort by your stuff. So this is what I've been creating on here. The last thing I have on here is my other program. So everything you do automatically stores. And again, notice that the way students will usually present it is that it comes up with a stage. You can click start, you can run the code, and then you can even like full size this, and this is kind of like is the execution of the program hiding all the code. Alright, so if I downsize that, you can click see inside. You can also click share if you wanted to share this with kids or share your work with the community. They'll need to click that share button, which is also right at the top here. So this is the code we just made for the probability. If you wanted the population to happen slower, notice I have this wait block. So in between every looping through, I could actually make a small pause in there, like 0.2 seconds, and notice what that looks like. See how it kind of slowly populates if you wanted that animation type thing to happen. And then I was just going to show this code for those that are maybe more advanced at the moment, or really it's not that hard to consider. So let's look at the variables I added. So I went into variables and I added a summation concept. So you needed a variable to total up the list. So I'm initiating that to 0 every time for this. I'm making a counter so that I can actually look through or index the pieces of the list, like this is the first position, second position, third position, and so on. And so I created a counter that initiates at 1 to start here and then slowly trickle down. So I'm going to repeat this summation concept for the full length of the list, in this case 10, and I'm going to set the sum to the previous sum plus the item at the counter number. So that would be kind of scrolling through. So it would be counter number 1, but then notice that I've incremented or changed that counter to notch up by 1. So then counter would now be 2. So as it loops through the second time, it's going to take the previous sum, which would have been 2, and add the next item in the list, which is now the counter value is 2, which would be 6. And then each time it loops through, it's just going to keep scrolling down or indexing to the next value. And then at the end here, I set the average to that total sum. Once this looping is finished, take the total sum, divide it again by the total that there are to get the average, and then we're just displaying that average. So a couple pieces in there that could be helpful for a lot. And again, this algorithmic thinking is a pillar to computational thinking. It's the type of thinking we want students to reason through. And there's a variety of ways you could do this code. Hopefully that's helpful, and you can play around with different things. Another thing I will show to end with is, let's say I wanted to just explore the community. There are a lot of users out there. So if I wanted to look at another measure of center, let's say median, I can look at these and then I can explore their code. And kids do this all the time. So if I click this particular program, let's say, and I want to find the median code, you're going to find that some of it is just too much to follow. Like this one's too much to follow for me. So I might go back and search the community for median and find a different program to follow. So this is just something to consider as you play around and gain confidence. And if I click see inside on this one, notice it's just the median. Again, a pretty complex algorithm, but I bet you could pull some ideas from it. So hopefully this was helpful, and you got some value from the conference overall. Thanks again.